Surrounding the coast of Antarctica are massive floating sheets of ice called ice shelves. Because they sit right on top of the seawater, they act like giant physical brakes, holding back the colossal glaciers of the land-based ice sheet from sliding straight into the open ocean. Scientists have known for a long time that warm ocean currents are slowly chewing away at the undersides of these ice shelves. But in 2026, a research team led by Madeline Youngs discovered a massive blind spot in our climate models. They documented an invisible mechanism happening deep underwater that acts as a hidden accelerator for this melting process. This newly observed cycle is so powerful that it could add an extra 0.2 of a meter to global sea level rise by the end of the century. The threat to our coastlines is severe enough that researchers are actively debating an extreme engineering response, physically blocking the deep water currents by constructing massive underwater walls. The survival of global coastlines relies on understanding exactly how this invisible underwater machine works and figuring out if human engineering actually has the capacity to shut it off. Here are the mechanics. Warm, salty, circumpolar deep water is normally blocked by a cold water shield. When warm water touches the ice, it releases fresh meltwater. This added freshwater decreases ocean density, dissolving the cold barrier and allowing warm currents to rush straight up. This creates a relentless, self-accelerating cycle. More warm water causes more melting, which produces more freshwater. That freshwater further thins the barrier, inviting an even larger volume of warm ocean currents to wash against the ice. According to the new models, this single feedback loop accounts for roughly 2/3 of the total bottom melt expected across all Antarctic ice shelves. As the ice shelf thins, it loses its ability to buttress the land-based ice sheet, allowing glaciers to flow more rapidly into the open sea. To physically break this natural loop, some researchers have proposed constructing enormous sea curtains, or underwater walls, anchored directly to the seabed. Looking at this animated diagram, you can see how the wall operates. It physically intercepts and deflects those warm, salty currents. By blocking the incoming heat, the structure traps cold water securely against the ice shelf, restoring its lost armor. Building a structure this large carries an extreme price tag. Estimates suggest a single installation could cost between $40 and $80 billion. We use barrier concepts like this in coastal engineering to protect shorelines near populated cities, but attempting to scale this technology to span hundreds of kilometers beneath an Antarctic ice shelf has never been done. We are seriously evaluating the most expensive underwater mega project in history, largely because this natural feedback loop is completely resistant to normal interventions. Theoretical diagrams make the installation look clean and highly controlled, but this is what the surface actually looks like. The area directly above the build site is a chaotic, hostile expanse of broken sea ice. Heavy lift supply ships must cut through ice up to 1.5 meters thick, while construction crews would face surface temperatures that drop below -60 degrees Celsius. Then there is the physical threat to the wall itself. Any structure submerged in this environment would sit directly in the path of unpredictable icebergs, ranging from small submerged growlers to chunks of ice the size of cities that would easily smash the barrier. Because engineers would have to drill safely through 2,000 solid meters of ice to reach a high-pressure, deep ocean seabed, scientists studying the hidden melt conclude that fixing the problem with current technology is virtually impossible. The brutal physical laws of Antarctica ensure that we cannot rely on science fiction megaprojects to act as an emergency brake for the oceans. While some discovery rangers point out that localized geoengineering might serve as a distant backup plan, it offers no immediate protection. The freshwater feedback loop is out of our physical control. It is active right now, and the data shows it is already accelerating. With engineering solutions currently out of reach, scientists point toward a more direct variable, the heat of the ocean itself. Reducing greenhouse emissions remains the primary method to lower water temperatures and slow the hidden melt. Targeting the warming at its source remains the most direct way to limit this feedback loop before it pushes sea levels beyond current predictions.